Everyone, welcome. Today we are diving into the world of pH, a critical concept in chemistry. We are going to tackle some common questions about pH for acid, bases, and those amazing buffer solutions. So let's get started. Our very first question one says, what is the pH of zero point 0.2 molar sodium hydroxide solution? How do we calculate that? Let's look at the solution. Sodium hydroxide is a strong base, meaning it dissociates or ionizes completely in water according to the equation given. Sodium hydroxide ionizes to give sodium plus OH minus. 0.2 molar sodium hydroxide solution implies the concentration of OH ion in solution is 0.2 molar. Let's calculate the pOH. pOH is given a negative log of hydroxide ion concentration, which gives us negative log of 0.2 molar, and we have 0.7. Now we know that pH plus pOH is equal to 14. Making pH the subject of the formula gives us 14 minus pOH, which is 14 minus the calculated 0.7, that is 13.3, and that is our answer. Let's move to our question number 2. What does it say? What is the pH of 0.05 molar hydrochloric acid? How do we solve this question? Let's look at the solution to the question. We equally know that hydrochloric acid is a strong acid, and therefore it would dissociate in water or ionize in water completely according to the equation. HCl dissociate in water to give H plus, that is hydrogen ion, plus Cl minus, that is the chloride ion. 0.05 molar hydrochloric acid equally implies the concentration of the hydrogen ions in solution is equals to 0.05. Now we know that pH is equals to negative log to the base 10 of the hydrogen ions concentration. That gives us negative log to the base 10 of 0.05 molar, and that gives us 1.3 as the answer to the question. Therefore, we say that the pH of 0.05 molar hydrochloric acid is 1.3. We continue with question 3, and on this question, we are going to be looking at a question concerning a buffer solution. The question reads, a solution made up of 0.1 mole per dm cube propanoic acid, the acid constant Ka is given as 1.35 times 10 to the negative 5 mole per dm cube and 0.35 mole per dm cube sodium propanoid constitute a buffer solution. Calculate the pH of the solution. We know that buffer solutions are solutions that resist changes in pH upon the addition of small amounts of acid or bases. In calculating the pH of buffer solutions, we use this equation here. This equation is called the Henderson-Hasselbalch equation. We know that a buffer solution is usually made up of a weak acid and its conjugate base, or a weak base and its conjugate acid. In this case, we have a weak acid and its conjugate base. The acid is propanoic acid and the base is sodium propanoid. Going back to our equation, pKa is the acid dissociation constant. A minus is the concentration of the conjugate base, which is sodium propanoid, and AH is the concentration of the weak base, which is propanoic acid. Let's continue by calculating our pKa value. pKa is calculated as negative log to the base 10 of the Ka value, which is negative log to the base 10 of 1.35 times 10 to the negative 5 moles per dm cubed. That gives us 4.87. Now we are going to plug in our pKa value into the equation. When we do that, it's going to imply pH is equals to 4.87 plus log of the concentration of sodium propanoid divided by the concentration of propanoic acid. That gives us 4.87 plus log of 2.33. And when we do that, we have 4.87 plus 0.35. When we sum that, it's going to imply therefore that the pH of the buffer solution we have just calculated is approximately equal to 5.24, and that is our answer. Summarily, we have calculated the pH for strong acids, strong bases, and buffer solutions, and here are the key takeaways. Strong acid and bases ionize or dissociate in water completely. Use pH equals to negative log to the base 10 of hydrogen ions concentration to calculate for the pH of acid, and negative log to the base 10 of the hydroxide ion concentrations to calculate for the pOH for bases. To calculate for the pH for bases, use pH plus pOH equals to 14, and use the Henderson-Hasselbalch equation to calculate for the pH of buffer solution. Thanks for watching and see you in our next video. Bye bye.